Hello, Assalamualaikum. Hi, my name is Muhammad Fazlin Hazim Membase and I am from Material Engineering, and my group members are Muhammad Aidil bin Ahad Kuyong Siong, Muhammad Zohirul Haziq bin Aziz and Wong Kok Keng. Our group is under supervision of Dr. Woon, and today we are going to present about the evolution of soldering material. Okay, first I will present about the soldering material. So, what is soldering material? Soldering is the process of joining metal by a fusion of alloy with have relatively low melting point. Soldering also use a metal that has a low melting point to adhere the surface to be soldered together. There are different type of solder used for electrical application nowadays. So, usually can be classified as a thin lead solder or lead-free solder. The soldering material of eutectic alloy is that commonly used is 63% of tin and 37% of lead. So why tin lead commonly used nowadays? They are good wettability on copper, good plasticity, low melting point, and the most important are reasonable electrical conductivity. In other hand, lead PB can reduce the surface tension of pure tin and the lower surface tension of SMPB solder due to facilitated wetting. Okay, now let's see about how solder melt. Boost clean and hot enough is the major factor to justify the solder bond with metal. So, before beginning the solder process, need to add a little solder to the soldering tip and then clean. Or you can use tip cleaner. So, this process called as a tinning process. Tinning must be applied to make sure that transferring of heat to boost of the component lead and the circuit board pad can be achieved. If the tip is dry, it is very difficult to solder. So the joining is hot and wetting take place, solder will flow easily and quickly making a strong joint. The role of temperature is very important in this matter, which will affect the quality of the conductivity. In solder melt, fusion must occur at around 180 degrees Celsius to 190 degrees Celsius, while for the most common lead-free alloy, the fusion occurs approximately at 220 degrees Celsius. Hence, it was necessary to increase the temperature of the solder tool to achieve a solder joint in the same length of time. If solder time is increased, so the component and the printed circuit may be damaged. So this is the effect of the overheating and lower temperature. So overheating will effect of localized overheat of the connection area and then produce in pole solder joint, overheated solder, board damage, and due to increase in oxidation. While for lower temperature will effect of poor heat transfer, poor quality solder connection, and resulting in low productivity. Wettability also is the most important thing in soldering material. So, wetting is the condition where the solder has become molten at its eutectic point. So, in soldering, wetting takes place orderly to allow the joining material to interact with the workpiece surface. Allow the molten solder by capillary action, where capillary action is the ability of a liquid to flow in a narrow area without the assistance. In this case, the capillary action will allow solder material to fill a joint gap or through hole in the printed circuit board, or called as a PCB during soldering process. The formation of a reliable joint depends on a good wetting between the joining material and workpiece. Wetting time decreases with increasing temperature for all alloy, where good wettability is the less temperature dependent. So this image show the solder droplet condition, where the good wetting condition show more small contact angle, where for full wetting condition show more large contact angle. So that's all for my part. Thank you for watching my video.
Good morning. My name is Muhammad Aidil bin Ahad, and my matrix number is 15104072. For the group assignment in Electronics Material Engineering, my group, which is under Dr. Woon, is presented to the topic of process of soldering. Moving on, there are generally three processes of soldering. We have soft soldering, hard soldering, and brazing. For soft soldering, it is carried out with a soldering iron at a lower temperature. For hard soldering, it is carried out at a higher temperature and it is carried out in a brazing hearth. For the last process, which is brazing, it uses the highest temperature and it is also carried out in a hearth. but it has the strongest connection since it uses a highest temperature. Let's look at process of soldering in electronic industries. In electronic industries, generally it falls into three categories, which is lead-based solder, lead-free solder, and silver alloy solder. Lead-based solder, it is used an alloy from tin and lead. It is most commonly used because lower melting temperature of the alloy is important because electric components are very heat sensitive. For lead-free solder, it is made with alloy of tin, silver, or copper. It does not have lead. It is more expensive, but it provides a stronger solder joint. Also, it is very environmental friendly. For the last category, which is silver alloy solder, it is added a silver in the alloy, a silver component in the alloy to prevent silver migration effect when silver plated components were soldered. That is all from my part. Thank you.
Hi everybody, my name is Ko Yong Seong from School of Material Engineering. Today I will discuss about the evolution of soldering materials. There are 5 types of production of soldering material, which is the lead-free reinforced by the nickel coat alumina, silver graphite nanosheet, ceramic, and the zinc oxide nanoparticles. Okay, first we discuss about the production of the lead-free solder reinforced by the nickel coat. This is the flowchart of the production. First, the graphite nanosheet coated nickel is prepared by using the different step, which is the ultrasonic dispersion, sensitization activation, and the nickel electrolyte plating. Then it will mix with the solder powder by using the milling process, and then you will press into a cylindrical shape. Then it bring into the sintering process. The final product will be the lead-free coated graphite nanocomposites. Okay, next is a production of the lead-free reinforced by the nickel coat alumina nanoparticle. This is the flowchart of the production. To make it easier, the nickel coat alumina nanoparticles is mixed with the primary ribbon, which is the lead-free solder, in the process of the mill spinning. Then the mill will be rapidly cooled under a rotating water copper well and form a secondary ribbon. Then that is the product. Okay. Next, we discuss about the production of the lead-free solder reinforced by the silver graphite nanosheet. This reinforcement is to improve the thermal stability and the tensile strength of the solders. First, we need to prepare the silver graphite nanosheet particles. Then it is mixed with the lead-free solder powder by using a milling process. The melted powder is then hydraulic pressed into a cylindrical shape and bring it to the sintering process. The sinter product will be extruded into a desired shape. Okay, this is the production of the lead-free solder reinforced by the ceramic nanoparticles. The ceramic nanoparticle, which is the nanosilica powder, is prepared by the synthesis of the silicon polymer by using a process of pyrolysis. The process is almost the same by involving the milling process. The melted powder will be compressed into a cylindrical shape and bring it to the sintering process. The final process is extrusion of the sintered product at the room temperature. The reinforcement is to enhance the tensile, yield, and the compressive strength of the soldering material. Last but not least, the final is the production of the lead-free solder reinforced by the zinc oxide nanoparticles. The zinc oxide powder that has prepared is melted and mixed with the lead-free solder melt by using the electromagnetic stiller. The melt is then cast into a steel mold by an air cooling condition to create the fine microstructure. This reinforcement is to enhance the yield strength, ultimate tensile strength, and increase the creep resistance of the soldering materials. Okay, now let's talk about the production of the powders. The centrifugal atomization is a conventional technique to produce a very fine powders of the solders. A fine solder powder is needed for the prepare of production of soldering material. The more fine the powder, the more the surface area, the more the viscosity of solder paste will be. Okay, this technique also have some limitation, which if the mill do not pour into the center of the rotating disc, the high speed disc will become unstable and difficult to form a stable liquid form. The feed rate is restricted and the liquid form must be thick enough. Even though the rotating speed is increased, the average size of the powder will be produced between the size of 13 and 15 micrometers. A hybrid atomization is a new technique to overcome the limitation of the centrifugal atomization. A hybrid atomization involves the combination of the gas atomization and the centrifugal atomizations. For the gas atomizations, it involves the addition of the two gas nozzles systems. The gas will flow from the gas nozzle with an inclination angle and hit the male jet that flow from the top of the TANDIS and form a thin liquid film at the edge of the atomizer disc. The atomizer disc will scatter the thin liquid film into the small droplets. The small light fine particles will form within the range of 10 micrometer or less compared to the centrifugal atomizations. Alright, that's all for my part. Thanks for watching.
Hi and Assalamualaikum. I am Muhammad Zohirul bin Aziz from Architecture Material Engineering, and now I want to talk about the application of soldering material. First of all, I want to introduce the difference between soldering and welding because it is look same behavior but it have different method. For soldering, we heat the metal to be bond, but we do not melt them. For welding, we melt to the metal to bonding together and make the filler metal that we use to make the bond. Okay, now the application of soldering is used in electronic, plumbing, metalwork, and jewelry. Soldering is connection that eternal but invisible connection between copper pipe in plumbing as well as joint in sheet metal objects such as food cans, roof flashing, and automobile radiator. For the jewelry tools or components, and some machine tools normally repaired by the high temperature soldering process. Soldering application also used to joinery and copper foil in stained glass. Okay, next. In this application, the material that use copper, which is the most commonly used for peculiar element as a substrate in electronic application. Cu also have ductile metal having higher thermal and electrical conductivity. Then, Cu also is a great element that can produce electricity. In addition, Cu can be classified as superior corrosion resistant, striking color, and good mechanical properties. And Cu also can transform to so many shapes and sizes. As we know, it is potential impact on the electronic industry, and Cu as an excellent for the heteroepitaxial growth of diamond because Cu produce no carbide. Okay, next, in this application, we know that the difference of material is used to different of the application. For example, porous. Porous is used in the manufacture of print circuit board because porous will better crystallize and pose greater relative surface. In an application, the substance of the element and processing are effect to the quality of a solder. Now here, there are many factors affecting the quality of solder that cause process is very strong, such as manual solder paste printing, main parameter, and used to printing stencil printing manual. Lastly, we are according to the practical training for solder to avoid loss caused by failure of solder paste. In the end, thank you for watching my video.
My name is Wong Kok Kian. Today I'm going to present challenges in implementing alternative solder material. Thin lead solder is a very good solder material. However, the toxicity indeed will cause huge and irreversible damage to the humankind and the environment. Thus, it has been banned by the Restriction of Hazardous Substance Directive. A new and alternative solder material are invented and researched. However, there is some limitation in implementing them. These are the factors that limiting the alternative solder material. First of all, there's high processing temperature. Normally, lead-free solder has a processing temperature around 230 degrees Celsius to 250 degrees Celsius, which is higher than their melting temperature. For example, SSC305 solder has high processing temperature around 242 degrees Celsius. This processing temperature will cause an irreversible damage and defect to the electronic component, which will make it hard to be reworked. That's why it is only applicable to high thermal properties product. Next is poor wettability. Wettability is an ability to adhere on a surface properly in order to promote conductivity on the solder joint. A poor wetting solder can lead to cold solder joint, crack in solder joint, and defect solder connection. All these problems are caused by the high preheat temperature, presence of physical barrier between the surface to be joined, and oxidation occur on the solder joint. For example, tin zinc and tin silver solder have the poor wettability. The figure on the left shows the wetting angle. The delta C cannot more than 90 degrees to have a good wetting properties. And the figure on the right shows all types of solder joint could be happen. Next, followed by the high cost factor. Unique elements such as indium, antimony, and silver are normally used in lead-free solder. The raw material will affect the quality of a solder material. Thus, large investments are needed for manufacturing alternative solder material by using these unique elements. Hence, the production costs of lead-free solder are much higher than the conventional tin lead solder. Besides, the scientists are lacking of research data. There are limited knowledge in production of good and new solder material. Not all the elements in the earth are well studied and explored. Hence, the insufficient data and analysis on the new element. Maybe there are some consequences of the usage solder which are yet to be discussed, such as silver can actually toxic the aqua light. Last but not least, the weak chemical and physical properties is concerned as well. A lead-free solder will get oxidized easily, hence corrosion will be occur. Next, the microstructure on the solder joint will be unstable at the elevated temperature, and cracks are observed easily at this higher temperature, result in the shear strength on the solder joint will be reduced. In conclusion, solder material is good in joining two objects. It changed from lead solder to lead-free solder. Although it has many flaws, it's still implementing in the industry nowadays. The society is looking forward more eco-friendly solder materials in application. Thank you for watching.